Hello everyone, welcome back to another video of Detangle. In this video we have an interesting question based on integration. So here we have integration of pi by 4 to pi by 2 cosec x whole raised to 17 dx, and the options are given like this. So here I'm not going to simply solve this, and I've already solved it, so that won't make any point. I'm just going to explain you how I will think. Say suppose I get this question in exam, how I would think and find the answer. So first of all, what I would do is, you can see that this integration is little complicated. You can't directly integrate it. So in such cases, always look out for the options. So your go card will be, just check out the option. You might get some hint. That is, here as you can see, even we don't have to integrate it. Why? Because they haven't integrated. The options are yet to be integrated. And another thing you notice is there is a change of variable. That is, the x variable is changed into u variable. So that is your first hint. That is, they have done a change of variable, that is from x to u, and also that means they have used a substitution method here. That is just a substitution, they didn't integrate it. So they have substituted x as u. So we need to figure out what is the relation between x and u. Second thing you notice is, here say suppose I'm looking for the first option. Here this 2 cosec x raised to 17, they have written it like this. Then maybe they took this 2 cosec x whole raised to 17 and they took this 2 out, and they 2 and this cosec x out, so that you'll be left out with like 2 cosec x whole raised to 16. So maybe they took this 2 cosec x as e raised to u plus e raised to minus u, that will be whole raised to 16, and then maybe when they substituted this variable, this substitution, then this 2 cosec x maybe have gotten removed. So that can happen, but we are not sure. Why? Because if you look into other options, so here and all it's still 17 there, so you can't really go on with it to find any other hints. So the third hint, what you can see is here the limits. Okay, so limits are like a very good way of understanding the connection. So as from the limits, I can roughly say that the variable they took, let u be, should be some function of log of something. So they have taken let u be some log function of some variable, 100%. And also as you can see that these numbers 1 plus root 2 here, which means that they might have taken this function cosec x. Why? Because here as you know, we are dealing with cosec x, and why I tell it should be cosec, it might be cosec x, is because say suppose you take the lower limit, that is x is equal to pi by 4. So if x is equal to pi by 4 in this, I am going to get u as log of cosec pi by 4, that is root 2. So I am going to get root 2 here, and also there is 1 here, which means that I am missing out a function here. So that missing function, as from the options I am going to substitute x is equal to pi by 4. So the function can be either tan x or cot x. Why? Because both at x is equal to pi by 4 you will get 1, which means that I need to confirm which of them is the function. So let me try out with the second limit, that is upper limit, x is equal to pi by 2. So for x is equal to pi by 2, you are going to get u is equal to log of cosec pi by 2, we know it is 1, plus if you have another function, it can be tan or cot, we don't know, we have to confirm it. But one thing we know, that if you put x is equal to pi by 2, maybe your limit should be 0. Why? Because here you are getting, say suppose here, if I assume I am getting log of root 2 plus 1 here I should be getting only log 1, that is 0. Why? Because the limits are given as log of 1 plus root 2 and another limit is 0. So we don't know for which one is which, but let's just assume for pi by 4 maybe we are getting root 2 plus 1, and for pi by 2 it should be 0, which means that here whatever the missing term, that should be, I can confirm that the missing term should be cot x. Why? Because then only if you substitute this, check this out, if I substitute this as log of cosec x plus cot x, then only here you will get this, that is at x is equal to pi by 4 cosec x is root 2 plus at x is equal to pi by 4, this will be 1, and also here if you see at x is equal to pi by 2, this will be 1, and here cot pi by 2 should be 0, so you will get log 1 is equal to 0. So if you are taking tan, what will happen is here it will go to infinity and you won't get this limit. So now this is a really good job done, that is you're getting the substituted term u as log of cosec x plus cot x. So far so good. So we have gotten an equation. We still have to verify if it is right or not. So let me check for the du and dx if it is right. So if I differentiate this expression here, so I'm going to get this as 1 by cosec x plus cot x, 1 by cosec x plus cot x whole into differentiation of this, that is cosec x is minus cosec x cot x, and cot x will be minus of cosec square x into dx. And here what I can do is I can take cosec minus cosec x outside, so that you will be getting cot x plus cosec x, and that you can cancel with this, so you will be getting minus cosec x dx. So that means if I am understanding as per the question, they have done this step, that is they have separated this 2 cosec x whole raised to 16 and the 2 cosec x outside. Why? Because then only when you integrate this, they have taken this cosec x dx as du, which means that now I know the option should be either this or this. Still there is a confusion between e raised to u this or this. Why? Because this is 16 and 16, so it can't be 17. Why? Because this is the relation between du and dx. So they have eliminated one cosec x dx here and they have written it as du, and here there is still confusion between whether if it is e raised to u plus e raised to minus u or e raised to u minus e raised to minus u. Now to check between these two options, we have to see that here this 2 cosec x is written in the form of e raised to u plus e raised to minus u, or this one. So that means here this expression they have written it as, they have taken this log this side and they have written it as e raised to u is equal to cosec x plus cot x. So I'm getting something like e raised to u here. Okay, so we know cosec x plus cot x is e raised to u. Can I tell cosec x minus cot x, that would be e raised to minus u? So if you are not sure, I'll just tell you why. So we know this cosec square x minus cot square x is 1, right? Which means I can write this as cosec x plus cot x into cosec x minus cot x. So that means cosec x minus cot x is going to be 1 by cosec x plus cot x, and you know cosec x plus cot x is e raised to u, so 1 by e raised to u will be e raised to minus u. That means cosec x minus cot x is e raised to minus u. Then I can just add these two, so I'll be getting this will cancel and you'll get 2 cosec x is equal to e raised to u plus e raised to minus u, which means that 100% they have substituted this 2 cosec x as e raised to u plus e raised to minus u. So there you go, the correct option should be this one. So that's how you do it, and that's how exactly you should be thinking in your exams. Every question is going to be unique in its own way, so it is required that you think about it very critically and you try to connect everything. So that's what I did. So I hope this video was helpful, and I'll see you all in the next video back with another integration question. And yeah, thanks for watching.